Hello everybody. In the first question about the lift problems, we have solved we have found the apparent weight of a man in an elevator, and the elevator was accelerating with 2 meters per second square in the upwards direction. Now, if you look at the weight of a man of a mass 60 kilograms, you may easily find 60 times 9.81, you will find 589 newtons. If the elevator is accelerating upwards, then the reading on a scale that you see is not going to be the same as the weight of a man when it is stationary or in equilibrium on the earth. There will be a net force acting on the man, which will be in the direction of acceleration. Now, when you find that the net force acting on the object and subtracting from weight, you are going to find the normal force. And we have found the normal force acting on the man was 710 newtons. I just wanted to clarify once again that this 710 newtons is acting on the man, which is the normal force, which is acting upwards. And what we have said, this normal force should be equal to the force that applies by the man on the scale. That's why the reading on the scale will be the same as the normal force, which is 710 newtons. And what we call this number as the apparent weight. Okay? So this was the first question. I hope I clarified once again why we see 710 newtons on the scale when the acceleration is upwards with 2 meters per second square. What I'm going to solve now, if the elevator has an acceleration of 2 meters per second square and the elevator is slowing down. So in the second question here, elevator is slows down with 2 meters per second square, but it is going upwards. Okay? Therefore, acceleration in this case will be, again, the velocity is going upwards, this lift is going upwards, but it is slowing down. Therefore, I can say that acceleration in this case will be downwards, because it slows down. So, I'm going to ask the same question. What will be the apparent weight of this man when the acceleration is minus 2 or 2 meters per second square as the magnitude and the direction is downwards? I will put the free body diagram acting on the man. Weight of the man is acting downwards. Normal force is acting upwards. So in this case, it's important to identify the direction of net force and acceleration. According to Newton's law, net force is equal to mass times acceleration. And it is both of the net force and acceleration are vectorial quantities. Therefore, the direction of net force and direction of acceleration has to be the same. That's why I try to look at the direction of acceleration first, and I say, okay, this is the direction of acceleration, therefore it is the direction of net force, and I carry on with my calculations. I will do it that way first to see what I am going to get, and then I will just use notations to find the acceleration and net force. So net force in this case is downwards, because it is the acceleration has a downwards direction. Therefore, weight of the object should be greater than the normal force, which is equal to mass times acceleration. Weight is 60 multiplied by 9.81 minus normal force is equal to mass is 60 times 2. And normal force in here is going to be 60 times 9.81 plus 120 newtons, so you are going to get normal force. Let me just find this calculated quickly with a calculator. I'm going to get 709 newtons. So look at this value, which is smaller than the value that I got in the case when the acceleration was upwards. No, I'm making a mistake again, a calculation mistake here, because what I noticed that I have made a mistake, because this value should also be less than this value. Do you know why? Because it's accelerating downwards, therefore it should be less than weight, and I have noticed that this should be minus over here. So you should be also having this sort of double checks and understand your mistakes. So if I'm going to do this again, 60 times 9.81 minus 120. So that number is not 709, this is 469 newtons. And this should be less than this value, because this acceleration is downwards. The apparent weight should be less than your actual weight, because there is a net force which is acting downwards on you. Okay? And this is what you are going to see on a scale. So I am going to use only notations right now to solve this question. Let's say you don't know the direction of net force, acceleration is given to you as 2 meters per second square. What I'm going to say is, I'm going to take this direction as plus and take the downwards direction as minus. And I'm going to use again the same formula, which is net force is equal to mass times acceleration. Net force, in this case, N is in the positive direction, therefore N minus W is in the negative direction, that's why I am writing negative, minus W will be equal to mass times acceleration. And, I don't know, mass is 60 times 9.81 is equal to mass is 60 multiplied by acceleration. So acceleration either plus or minus. So let's look at the direction, is it up or down? So in this case it is slowing down with 2 meters per second square downwards, it's going upwards, but it is slowing down, therefore the acceleration has a downwards direction, and therefore acceleration has a negative value, which is minus 2. In here, you can get normal force as 60 multiplied by minus 2 plus 60 times 9.81, and you are going to get the same value, which is 469 newtons. Now the question I want you to solve is to find the tension in case acceleration is downwards with 2 meters per second square. Good luck.